Transformation of trigonometric functions. Question 2. Sketch a cycle for each of the cosine function. State transformation from parent function. So the parent function is cos x. Now, as I said in the first video, which was on sine function, this one is on cosine function. Very similar graphs, but shifted by 90 degrees, correct? That is the difference between sine and cosine. Just shift by 90 degrees and you get cosine function, correct? Now, it's a good reminder here that sketch means what? Sketch does not mean graph accurately, correct? Sketch means a rough sketch. The sketches which I am going to make here are good enough for you, okay? Let me just mention that. You don't have to do better than that, okay? Now, second part is state transformation from parent function. As I said, at times students really forget about the second part. They get so involved in sketching the function that they forget what else was required. Now, just to safeguard, I always write the transformations first. Because once you know the transformations, then you really understand what the sketch should look like, right? Now here, the transformation is vertical compression by a factor of half. So let's write down. So the vertical compression by factor of 1/2. That is it. So we got at least 0.5 marks of our question, right? Now let's do the sketching part. Now sketching, cosine function looks like what? So cosine function looks like this, right? So we'll just make a sketch of the cosine function, which is kind of like this. It starts with the maximum, goes through minimum, and then maximum, right? The maximum value of cosine is +1 and minimum is -1, right? Now in this particular case there are no translations, so we know it just starts from, so that's our y, correct? And the x-axis goes to the right center of this. So we'll draw, so the idea here is first sketch your graph, then the coordinate axis. I'll show you later how effective this policy is, right? And the third thing is write down amplitude. So amplitude has been divided by 2, and that means compression by half. So you got this as half here, and this dotted line comes here, and this is -half, and that is 0 for you. This is x, and this is y, and you know these points, right? So these are your critical points. So those who are doing with radians will do 2 pi and 360 degrees for rest of you, correct? And so these are pi by 2s, right? So this is pi by 2, this is pi, and this is 3 pi by 2, correct? And for those who are in degrees, they can fill up this and this with 90 and 270 degrees, correct? So that becomes your neat and clean sketch of the function with amplitude and time period, and that's what is required, correct? So let's move on to the next part. So it is that simple, do you understand? Now y equals to 2x plus 1. So here we got two transformations. One is vertical stretch, so let me write in short, vertical stretch by a factor of 2, and the other one is translate 1 unit up, right? So the other one is translate 1 unit up, right? So that is it. So, well, there's no reflection, all other things. So my sketch will again be same. That is, I'm going to sketch it like this. See again. So just get into the habit of doing it. Okay, that's fine. Now, since it is just going up and down, I know my x-axis has moved somewhere else, but y remains same. So let me just at least draw the y-axis. That's the whole idea. Let me draw the y-axis and then bother about the rest of the things. What else I know? Axis of symmetry has moved to +1. Now this was my axis of symmetry, so I'll draw a dotted line here, right? And so this dotted line should come at -1. Perfect. Now if this is at -1 and my amplitude is 2, that means I'm going 2 units above this. So if I go 2 units above it, -1 plus 2 will give me 1, right? And -1 minus 2 will give me -3, right? So it goes further down. That's it. That's how it is, right? So what really happened is this, and so let me just, and what happens to my time period? Time period remains same. So I'll say this is one cycle here, and let me fill this up. Now from here to here it is 360 degrees, right? And that's the middle of this somewhere. Okay, but I didn't draw my x-axis. Well, this is 1, this is -1, right in the center is my x-axis. So I'll draw my x-axis right here, and I will say, well, this is my 0, right? 0 is between 1 and -1, and that's my x-axis. And this point is 360 for me, this point is 180 for me, correct? And so don't put that as 90. 90 is here. Do you understand? 90 is here, and 270 is this point, not that point. So you have to be a bit careful about that part. So let me write, for my friends doing in radians, this will be pi, and you know this is pi by 2, and this is 3 pi by 2, correct? And 180 degrees. That should be good enough. X there and y there was 0, all these things. So we're done with our graph on this with these two stretches, correct? The last one is y equals to -2 cos x plus 1. I'm going to leave this for you, correct? Minus is reflect, right? So this will not start from the top but from here. That is how it is going to be. And it has to move. Oh, what I did here was -1. Oh my god. This was +1. So what I'll do now here is, I'm sorry, I just made it at -1, right? So instead of, I'll just do this question. Change this question. Translate 1 unit. Let me change this. Down. My mistake. I translated down, okay? Now I should have actually translated it up, right? Yeah, in my mind somehow I was thinking about doing minus and giving you plus. Anyway, so we made this change, right? So the question I made now is 2 cos of -x, and I translate 1 unit down. Because of this minus, I did this change because I shifted my graph 1 unit down instead of taking it 1 unit up, right? In any case. Now, so this part, let me do this for you now because I did a mistake there. So anyway, so minus means the cos will start from this side, right? So the minimum value comes first, not the maximum value. So I'm actually sketching it for you, and I'll give you another question, right? So we'll do it like this. We'll just go up like this and come like this, and it will be going like this, and it'll continue like this, correct? Now, in this particular question, we are going 1 unit up, right? So that is your axis of symmetry at +1. So that is my axis of symmetry. That is the point where I'll do +1, and I will write here +1. Now, amplitude is 2. That means from here I have to go 2 units up, so this becomes 3 for me, correct? This becomes 3 for me. Well, this is a fresh graph, correct? So there is a break in between, correct? Let me make use of whatever little space I have. Okay, so what I will do is I'll just make an arrow here saying this is my y. Perfect. And that's okay. That's good. So let's get back to the problem. 1 is my axis of symmetry, 2 units up and 2 units down. So 1 minus 2 will give me -1. Perfect. So now my x-axis between 1 and -1. So here I'll have a 0. So I'll just draw a line from here saying this is my 0, and so I get my x-axis now. See, just the reverse process from the graph to the axis, getting all details in between. So we got the amplitude, right, of 2 with maximum at 3 and minimum at -1. And axis of symmetry is at y equals to 1 because of this one, correct? Now think about this time. So this time, wherever the graph ends like this, right, wherever it ends, it actually ends here, so we'll draw here, right? This point on the axis is 2 pi for those who are doing in radians, and 360 degrees, correct? And this point right in the center is 180, correct? Or pi for those who are doing in radians. This is in degrees, correct? But remember, that is 90 degrees, correct? Don't mark this as 90. That will be wrong, okay? Now, and this is 270 degrees for you, correct? So that is your graph for -2x plus 1, correct? And you can always write down your transformations here. 1 is reflection on x-axis. 2 is vertical stretch by a factor of 2. And this one is 1 unit up translation, vertically 1 unit up. So those are the 3 transformations for this. To give you a problem to practice, what I will do is do the combination of these for you. correct? So let the problem be f of x equals to minus half cos x minus 1. Okay, so try to draw this graph, and when you do graph of this, write down its domain and range, time period, okay, and if possible find zeros. Okay, if possible find zeros. You have seen here that zeros are not at 90 and 270 degrees, correct? Zeros shift. So in this graph, find zeros. That is a big exercise, correct? Thank you.